Hello, it is 12:36 a.m. It's November 11th. Happy Veterans Day. Um Today's Leetcode problem is called Design Graph with Shortest Path Calculator. So it's a class design problem, plus we need to run a graph traversal as well. This one, I agree, it is pretty hard. I needed to know this graph traversal algorithm called Dijkstra's algorithm, and I didn't know how to do it, so I had to pretty much completely copy it. So that's 2 days in a row of copying. Shame on me. But let's talk about the problem. So our entire graph is going to be a list of a pair of integers, and this pair of integers, I'm guessing, is going to be the neighbors and the weight. But we'll see. So first you create the graph like this. You're given an int n, size n, and a 2D array of edges. The first element of, the 2D array element part is the value of the first node, the value of the second node, and the weight of the edge. And you're given multiple of these to draw out an entire graph. And I start off with an array list, and what we do is we initialize a new array list for every one of these, and for every edge we want to set the because for all the node values themselves, not the weight, the node values themselves will be ranging from 0 to size -1. So we get this, and we add the pair of what we get? We get the neighbor, and we get the edge weight, and we could get multiple of these. So adding edges is pretty simple. You're given the starting node, the end node, and the weight in an array. And what you do is you take the starting node and you add a new pair involving the neighboring and the weight. So the shortest path algorithm follows Dijkstra's algorithm, which is an algorithm for finding the shortest path from one node to another, by pretty much going through it and finding the smallest path like this, and in the end it should look something like this. And we do something similar here. We keep an array of the costs. So we fill the cost array with the integer max value because we want to overestimate, because we're looking for the minimum. And we set the starting node to 0 because we start there. And what we do is we add the node into the priority queue. So we kind of sort it. So while the priority queue is not empty, what we do is we take the minimum current node, we get the cost, and we get the node value. We check if it is optimal or minimum. If it's not, then we want to continue. However, if it is optimal and we want to do more calculations with it, we can either check if it's the target, in which case we would just return, or we would check every neighbor for the list. So in this example, we go from A to C. We would check every neighbor, so we would check from B, D, and E. So, and then we would assign values to these new neighbors. And for every neighbor in the list, right, we get the neighboring node, we get the neighboring cost, we get the new cost, which would be the cost of traversing from A to C. So it would be 2 plus 1 for A to get to B. And it would be 2 plus 4 from A to get to D. And it would be 2 plus 5 to get to E. That's calculating the new cost. If it is optimal, then we want to update the cost of the neighboring node to this cost, because that's the That's the easy. That's the way to get there with the least amount of cost. And if this new cost is less than the cost of the neighboring node, we want to update the neighboring node. And we want to add these B, E, and D to the priority queue because we want to check if there's faster paths to get through this. In conclusion, this was a great lesson for me. I don't think I would have been able to do it even if I knew Dijkstra's algorithm. But yeah, I'm humbled once again. Don't get my hopes up, Leetcode. Don't get my hopes up. But thank you for watching. I'll see you tomorrow. Holy shit, the memory sucks.